Good morning, one and all. In this video lecture, I am going to discuss armature reaction. Armature reaction is a topic under DC machines. On completion of this video lecture, you will be able to know explanation about armature reaction with a neat sketch. Before entering into the armature reaction, first we have to know what are the varieties of flux are involved in armature reaction of DC generator. In armature reaction, there are two types of fluxes are involved. The first one is armature flux and second one is main field flux. Now, what is armature flux? What is main field flux? First, we have to know about these two fluxes. Then, why it is called armature reaction. Now I will entering into the next slide. I have to know what is armature flux and what is main field flux. Now first we will know what is armature flux. Armature flux, when a current flowing through armature conductors, flux is set up around it. Now this is image of armature core having slots and each slot is accommodating with one conductor as shown in this figure. And in these conductors, current is flowing. When current is flowing in the conductors accommodated in the armature slots, develops a flux around these conductors. When current flowing in these conductors, a flux is shown like this. This is a flux setup in armature conductors is armature flux. Once again, when current flows through the armature conductors, flux is set up around it. This flux, the flux set up around the armature core, is known as armature flux. This is explanation about only armature flux. Now, the next flux is main field flux. The flux under main poles is called main flux. I am explaining two fluxes separately. Means when I am talking about armature flux, I am not considering main field flux. You can see this is the field poles. This is another field pole. I am not mentioning this is north pole, this is south pole, or this is north pole, this is south pole. Why? Because my intention is to explain what is armature flux only. During explanation about main field flux, I am not considering the armature slots on the armature core. You can see the difference here during this armature flux explanation. The winding does not carrying any current. You can see in this picture, this pole is carrying a current like this. During this time, the armature is not carrying any conductors and there is no fluxes developed in the armature core itself. Now, this explanation about main field flux, that's why I'm considering only field winding on poles. By giving a by wounding around the poles and giving a current, it is exhibiting a north pole here and south pole is here. During this, always the flux lines starts from the north pole and entering to the south pole. These flux lines are called main field flux. Okay, the flux developed around the armature core, set up around the armature core is called armature flux. The flux under main poles is called main field flux. Underline main poles. There are compoles are also there. Those compoles are also called interpoles. I'm not talking about interpoles. I'm talking about only main poles. The flux under main poles is called main flux. This is main field flux and this is armature field flux. Next slide. What is armature reaction? Armature reaction, it is an effect set up by the armature current on the distribution of main field flux. Simply is known as armature reaction. It is a reaction which is set up by the armature current. When armature is passing some current, it is developing armature flux. That armature flux is giving a reaction on main flux. The reactions are two types. One is demagnetizing effect. Another one is cross magnetizing effect. The flux set up by the armature current is weakens the main flux. When the main flux is weakens, reduces the generated voltage. According to EMF equation of DC generator, EG is equal to pi Z and P divided by 60A. In the above equation, EG is directly proportional to the flux. When flux is reduces, generated EMF reduces. When flux increases, generated EMF will also increases. But the effect coming from the armature current, that effect, one of the effect is demagnetizing effect. During the demagnetizing effect, it weakens the main flux. When the main flux is weakens, the net amount of flux is reduces, which in turn induced EMF is also reduces. The another main effect by armature reaction is cross magnetizing effect. Cross magnetization means the main flux is distorts the wave and results in sparking at brushes. The main flux is having one flow of magnetic flux. That magnetic flux flows is distorts. Distorts means it's shape out. Simply says shape out. It shape out the main field flux. Due to that, sparkings are take place at the brushes. These are the two problems with armature reaction. Now, tell me what is armature reaction? Armature reaction, it is an effect set up by the armature current on distribution of main flux is known as armature reaction. The flux set up by the armature current may weakens the main flux or distorts the main flux. By weakening the main flux, net induced EMF reduces. By distortion of the main flux, sparkings or takes place at the brushes. These two effects are called as demagnetizing effect and cross-magnetizing effect. In this slide, I am going to explain what is armature reaction and what are the effects of armature reaction. Next slide. There are some terminologies are involved to explain this demagnetization effect and cross-magnetization effects. GNA, geometrical neutral axis. You can see in this picture, North Pole, South Pole, MNA, GNAs are shown. The geometrical neutral axis is, it is an axis between adjacent and opposite poles. It is an axis between adjacent poles. Suppose this and this are adjacent poles. Then axis between these poles is, it is the axis. When there are two poles this is the axis when two poles are there. Suppose if this is a 4-pole generator, for this pole, this will be the adjacent pole. Then it is an axis between the adjacent poles. At that time, I am drawing by arrow lines a line that is the axis, geometrical neutral axis. But I am considering here only 2 poles DC generator. For this shown figure, this is one pole and this is another pole. If this is a north pole, the opposite pole for the north pole is south pole. Between these two poles, axis is exactly is midway. That axis is called geometrical neutral axis. There is another important term, MNA, that is called magnetic neutral axis. Magnetic neutral axis is simply axis perpendicular to the armature flux along which no EMF is induced. MNA is axis perpendicular to the armature flux MNA may be defined as the axis along which no EMF is generated in the armature conductors as they move parallel to the flux lines. Brushes are always placed, you can see here, the brushes are always placed along the MNA because Reversal of current in the armature conductor takes place along this axis. MNA axis is very important. Brushes are placed in the MNA axis, and the conductors, one side of the brushes having one direction of current, the conductors another side of the brushes is having another direction of current. Means when this conductor, if it is rotating in clockwise direction, it crosses the MNA axis and entering into the another pole, then the current direction is changes. Means suppose if this is having plus 2 amperes, then it is coming to plus 1 ampere, then 0 ampere, then minus 1 ampere and minus 2 amperes of current. When this conductor is crossing the MNA at one position, it does not carrying any current. Means EMF will not induce. Where EMF is not induced, that portion is called MNA axis. This MNA axis for the shown two-pole DC generator is same as geometrical neutral axis. But for taking four poles, this MNA and GNAs are different. Remember, underline, MNA and GNA are different when it is taking for four-pole DC generator. For here, I am considering only North Pole and South Pole. MNA axis as well as GNA axis is same on same line. Now, when this reaction takes place, which axis will shift, we will see. At that time, you know a clear clarity on which axis is does not change with respect due to the armature reaction. Yes, now in this slide, explained about geometrical neutral axis. It is axis between adjacent poles. These adjacent poles axis will not change when armature reaction takes place. These physical poles place will never change. That's why the GMA will not change. Geometrical neutral axis will not change. Then MNA is nothing but magnetic neutral axis. When the current does not induce, I mean voltage in which conductor will not induce, those positions having, suppose here also one conductor is there, then the opposite conductor is here. During this, EMF will not induces. Okay, that axis, what is happening during that, EMF will not induce. Axis, it is an axis along which no EMF is generated in the armature conductors. Why it is not inducing EMF in these conductors? As they move parallel to the flux lines. When they move parallel to the flux lines, these conductors will not cut the flux. There is no rate of change of flux. EMF will not induce. Now it is clear. Next slide. Terminologies involved. Continuation to the terms involved. TPTs and LPTs are another terminologies. LPT, leading pole tip. TPT, tailing pole tip. These LPT and TPTs are not fixed. These are depends on in which direction the armature is rotating. For the shown picture, it is rotating in clockwise direction. Please see, it is rotating in clockwise direction. During the rotation, the tip first met during the rotation is leading pole tip. Suppose if it is starting, when this armature is rotating, when armature is rotating in clockwise direction, first it will touches this tip. That's why this is called leading pole tip. Then this will leaves this tip. That's why it is called tailing pole tip. The tip met later during the rotation by the armature conductors. This is leading pole tip. Suppose if I am changing the direction of rotation, when the direction of rotation is changing, means now I am turning this into counterclockwise. When it is rotating counterclockwise, this conductor, suppose this conductor first crosses the ebony point. After that, it will touches this pole tip. Then this pole tip becomes LPT. Remember, this is TPT for clockwise direction. But when it is rotating in anti-clockwise direction, now TPT is not fixed. This is fixed during, depends on rotation of armature conductors on armature core. When this rotating in counterclockwise direction, first it will touch this pole tip, then this pole tip is called leading pole tip, and this pole tip will leaves this pole tip. The tip met later. First it will, this conductor first touch this tip, later it will touch this tip. Which this conductor first, which tip is touch, the tip is called leading pole tip, and this tip is called trailing pole tip. I think it is clear what is leading pole tip and trailing pole tip. In the direction of rotation of armature conductor, which pole tip will first met, that is called leading pole tip. The another tip is automatically called as trailing pole tip. Yes. Now I will entering into the concept of armature reaction. Once again, I am showing only main field flux. This is north pole and this is south pole. These are stationary field poles. In between these field poles, I placed armature core, and armature core is having armature conductors on its outer periphery, and there are two brushes are there where the brushes are placed on axis. In that axis, EMF will not induce. Why? Because these conductors are running parallel to this main field flux. Due to that, flux cut will not take place, EMF will not induce. Then these conductor where the brushes are placed, that axis is called magnetic neutral axis. That name itself is giving a clear explanation. Magnetically, it is neutral axis. Means it is not north pole, it is not under south pole. Magnetically, it is neutral. That conductor is not taking part of north pole and south pole. When this is not taking any north pole and south pole action, EMF will not induce. Neutrally, it is an ideal. The conductor is not taking part of magnetism, that is magnetically neutral axis. Geometrically mean physical. Physically, how the poles are placed. At the time of manufacturing, these physical poles are fixed. Then geometrical neutral axis is fixed. But MNA axis will change. Why it is changed? Now it is not changed during this explanation. Why? Because the armature is not carrying any current and armature is not developing any field around these conductors. In this figure, only main field flux is available, absence of armature flux. When during the armature, absence of armature flux, the flux lines are like this. Okay, I'm moving to next slide. Assume that there is no current in the armature current. I explained in my previous slide. Main flux is distributed symmetrically with respect to polar axis. Polar axis. Polar axis is simply, it is exactly the mid portion of the axis. Suppose this is north pole and this is south pole. Polar axis. Polar axis is the center of the, there is a line I am drawing by this arrow, this pointer. You can see here, this is polar axis. MNA coincides the GNA. In this picture, MNA is coinciding the geometrical neutral axis. There is a vector. This is origin O and this is a field F. Because of the main field flux, it is subscripted by M. Shows as magnitude and direction of main flux. You can see this is the direction of main flux, means north pole to south pole magnetic flux lines is moving. That is indicated by this arrow. Okay, and this magnitude is given by Fm, magnitude of flux is flowing from north pole to south pole, and this axis is MNA coincidence with the GNA during this explanation. This explanation, armature flux is absent. That's why this is the vector of direction of main magnetic flux. Next slide. MFF produces main flux and MNA is perpendicular to OFM. You can observe that magnetic neutral axis is perpendicular to main or polar axis, main field axis. Again, I said in the same slide explanation, this is the polar axis. Then MNA axis is perpendicular to the polar axis. Then armature flux. Previously, only main magnetic field. Now armature flux. When sorry, in this picture all are shown by the dots. That is not correct. I already said one side of the brush, if it is having a cross type of direction of current, then another side of the brush is dots. If these are the cross, then this is the dots. Then suppose we can consider a crosses on left side of this brush side, left side of the armature conductors. It is indicated by the cross or dots. When these are the dots, then the flow of flux direction is matching. When these are the cross, yes, you please change. Yes, I will change by using this with the help of this. This is cross, this is cross, this is cross, and this is cross, this is cross, and these are available with dot, 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 dot. Even if any conductor is available at this position, these conductors will not cut the flux, EMF will not induce, then there is no dot and there is no cross. During this, how flux is developing around a conductor can be found by thumb rule. Which thumb rule? Right hand thumb rule. The thumb indicates where the current is leaving or coming, or when the current is crossed or dots. Now, left side portion of the brush I am considered as dots. Then dot is nothing but current coming towards the observer. When current coming towards the observer, okay, then this is not matching. Yes, then I will change eraser with the eraser. These are not matching. I want to give a clear explanation. And these are cross. And these are dots. Okay, right. Yes, these are class. Please apply, all of you, right hand thumb rule. And conductors, no current carrying conductors. No current is developing. Yes. On left side portion of the brushes, I am applying right hand thumb rule. And the current is leaving or current is going from the observer. By applying the right hand thumb rule, my curling of fingers will shows like this. A flux is developing around this conductors is like this. Means for the conductor right side, current is coming downward direction. For the conductor left side, current is going upward direction. This is coming by applying right hand thumb rule. Next, for these conductors, I am applying right hand thumb rule. The current is coming towards the observer. By applying the right hand thumb rule, I have around this conductor, this side of conductor I am getting downward direction, this side of conductor I am getting upward direction of flux lines. This will change, the strength will change according to how much current is flowing in this armature conductors. Due to that, the left side portion of this conductor is downward direction. The right side portion of this conductor is downward direction. That's why the flux in the armature core is downward direction. And the magnitude is FA. You can see this is the flux due to armature flux. Assume that field coils are unexcited. Here I am showing this is north pole and this is south pole, but I am not shown with this flux lines. I am considering only one flux. Previous slide, I am not considered this north pole and south pole flux lines. Just I shown only this is north pole and this is south pole. Now assume that field coils are unexcited, armature flux set up due to the current in the conductors. And this type of flux is set up in armature conductors. Then vector OFA, you can see this is FA and this is O, origin, is parallel to the brush shows as armature MMF, both in magnitude and direction. This vector OFA, this is vector OFA is parallel to the brush axis. This is the brush axis. This is also called GNA axis. Okay, vector OFA is parallel to the brush axis. Now both fluxes are taking place in this figure. You can see because of this north pole, flux lines are like this, and I will change the color. And this is because of the armature flux. Due to that, it is giving two types of effects. Explained in my previous slides. Those two effects are demagnetization effect, cross magnetization effect. Due to this distortion, GMA is fixed at one place, but MNA is shifting. You can see this is MNA line. Previously the MNA line is here, but the new MNA line is shifted. Now why it is shifting we will see in the next slide. Both armature and main flux exist simultaneously. As in the same picture. In this picture, armature flux is as well as main flux both are exist simultaneously. Armature flux is non-uniform and non-symmetrical about the polar axis. Main flux is distorted. It is crowded at one tailing pole tip and weakens at a leading pole tip. I will explain here. This is main field flux. I consider here crosses. Okay, these are the crosses, not dots. During this, by applying right hand thumb rule, what type of fluxes are getting? This side is this type of direction. Why? Because I already told this is upward direction, this is downward direction. When this upward direction, I will get the flux lines like this. You can see here because of the main magnetic field flux lines. You can see here what is happening. I will explain here. This is conductor of cross. The flux available around this conductor is coming like this. This flux is set up by the armature current. Then I am having, because of the main magnetic field, flux lines are like this because this is north pole and this is south pole. You can see here, these both are in same direction. This side both are opposite direction. At this position, it is upward, it is downward. There is a flux. This flux is like this, and because of this line, flux is like this. There is a cross magnetization taking place. Here, one side is flux is increasing, and another side flux is decreasing, and mean net flux is decreasing. Here, flux is weakening. Here, flux is strengthening. Where it is strengthening, you know that here flux is strengthening, S is strengthening, then this is also strengthening. Here flux is weakening, then this is also flux is weakening. And this is rotating in clockwise direction. You can see here, this is the clockwise direction of rotation. During the rotation, this is touching this point first, then this is leading pole tip. When this is leading pole tip, this is tailing pole tip. For this north pole at the TPT, the flux is strengthening. When in TPT the flux is strengthening, here also the flux is strengthening, and the flux is weakening, and here flux is weakening. Due to that, I will show here the flux lines is coming here, and it will be like this. It will be like this. Now the polar axis is changing. Please see here, polar axis is changing. Previously the polar axis is center of the north and south pole. Now this is not center of the pole. It will come to here because of the armature reaction. Then it will come to here. Then the polar axis is, this one is the polar axis. You know that MNA is perpendicular to the polar axis. Then MNA is perpendicular to the polar axis. Then this will become the MNA. Then brushes are accommodated in the MNA axis. Then brushes are accommodated in the MNA axis. This is happening because of the armature reaction. Both armature and main flux exist simultaneously. Armature flux is non-uniform and non-symmetrical about polar axis. Main flux distorted. Now you can see main flux is distorted as is shown by the green color lines. It is crowded at a tailing pole tip and weakens at a leading pole tip. As I explained in my previous slide, leading pole tip, weakening, tailing pole tip, strengthening. Why it is called leading pole tip and tailing pole tip? Why? Because the direction I given first, this is rotating in clockwise direction. It is crowded at tailing pole tip. This is tailing pole tip, and this is leading pole tip. Sorry, this is tailing. If this is tailing pole, then this is also tailing pole. That's why the flux is crowded. Due to main flux distortion, MNA is shift through angle. Why it is shifted through angle? You can see how much angle is shifted, theta angle. Why it is taking place? Because of the polar axis shifted. Why it is shifted? Because of the armature flux is affecting on main field flux. Since brushes are always placed along the MNA axis, always the brushes will place along the MNA axis, not on GNA axis. You can see here, I explained already, GNA wheel is a physical axis. It never shift. When this is a pole and this is a physical pole, will never change. The axis perpendicular, the axis, it is an axis of between the adjacent poles, will never change due to armature flux, armature reaction. Due to this brush shift, armature current is redistributed. Armature conductors under the influence of north pole comes under south pole influence and vice versa. You can see previously this conductor, when this is MNA axis, this conductor is under the influence of south pole. By shifting this MNA axis, the same conductor now it is influenced by the north pole. Okay, right. This is the how the flux is happening because of armature flux after armature reaction. Armature MMF OFA resolved into two rectangular components. Then MNA is shifted, new currents are taking place apart from the brush side. One side of the brush is one side, another brush is another side. Then these are crosses. Then I will get a flux lines like this around this. Okay. Then this is OFA is resolved into armature MMF into two components. If this is, suppose this is armature flux, new armature flux. Why? Because the conductor's position is shifted. The armature polar axis is center of the armature flux. Previously, the armature flux is like this, but now the armature flux is like this because of the armature reaction. Now this is a new FA. Previously it is FA, OFA. Now this is OFA. Now this is resolved into two components. One is on horizontal direction, one is on vertical direction. Then this resultant OFA is divided into two components, FD and FC. Then the component is in this direction, which itself is indicates this is not the pole flux, and this is because of the armature flux. This is north pole flux, main flux. This is because of the one of the component of armature flux. Flux is opposing each other. What is happening? Due to this FD, flux is weakening, demagnetizing. Then this flux is like this, and main flux is like this. You can see main flux is like this. FC is FC component. Another component of this resultant FA is in downward direction. This is FC. Then this is main magnetic field, FM. Then these two fluxes are crossing each other. That's why it is called cross magnetization effect. During this flux and this flux, net flux is reducing. Because of the net flux is reduces, net induced EMF will reduces. Because of this cross magnetization, sparkings are takes place at the brushes. Then armature is resolved into two components, demagnetizing component and cross magnetizing component. Yes, I am going to conclude this video lecture demagnetizing or weakening the component on main flux. OFD, I have shown this one. This one is OFD. This is weakens the main flux, and this component of armature flux will cross magnetizes, which is nothing but distortion of the main flux. Both these effects increases with increasing in armature current. I said when there is no armature current, there is no effect. Only magnetic field line simply symmetrically passes from north pole to south pole. When the armature current slowly increases, this effects also increases how much current is increases. In this lesson, I discuss what is reaction, what is armature reaction. In armature reaction, I explain what is armature flux and what is main field flux. After that, I explain what are the effects are taking place during armature reaction, and I given a statement of armature reaction. Armature reaction is a reaction set up by the armature current on main field flux. During this armature reaction, it is giving two types of effects. One is demagnetization effect, another one is cross magnetization effect. Thank you for watching this video. I hope this video will definitely give a good concept about how armature reaction is taking place and how it is demagnetizing and how it is cross magnetization. Thank you.